This video is going to cover section 10.4, which looks at the blood distribution after it leaves the heart. And so we have two major circuits. We have the pulmonary circuit and we have the systemic circuit. So the pulmonary circuit, it circulates blood throughout the lungs, and then the systemic circuit, it circulates blood to the body tissues. So obviously this is not drawn to scale, but you can see once again on the right side we have the pulmonary system, and then on the left we have the systemic system. And for the pulmonary system, we have blood coming from the body through the superior here and the inferior vena cava, which is then pumped to the lungs. So it's oxygen poor blood that is pumped to the lungs, and then um, those vessels, they carry oxygen rich blood back to the left side of the heart, which is then pumped throughout the body. So the pulmonary circuit then, um, the blood first enters the right atrium, which then goes into the right ventricle, which is then pumped through the pulmonary trunk, and it divides into the right and the left pulmonary arteries, which then branch into arterioles. And the arterioles then take blood to the pulmonary capillaries, there where the gas exchange occurs. And so then oxygen-rich blood passes through pulmonary venules, which lead to pulmonary veins, which then enter into the left atrium of the heart. And then from the left atrium then into the left ventricle, and then is pumped throughout the systemic circuit, and this circulates blood to the body tissues. And the aorta and the vena cava, they serve as the major pathways for blood in the systemic circuit. So the path of systemic blood to any organ, it begins in the left ventricle, as we mentioned, and then we can trace the blood to and from the legs. So from the left ventricle to the aorta, the common iliac artery, and I'll see if I can highlight those here for you. Common iliac artery, which would be down in here. So the aorta essentially bifurcates here then into the common iliac artery. And we have a right and a left then. From there, the femoral artery, of which, once again, we have a left and a right. Then to the leg capillaries, and then from there, then it begins its journey back to the heart through the femoral vein, then the common iliac vein, the inferior vena cava, and then once again to the right atrium. So blood pressure, as blood passes through the blood vessels in the body, it exerts pressure against the vessel walls, which is referred to as blood pressure. So we have the systolic pressure, and this results from blood being forced into the arteries when the ventricles contract. So the systolic pressure then is from the powerful ventricles contracting, and therefore that's the first number that's referred to with blood pressure, and that is the systolic pressure. Then you have the diastolic pressure, and this results from pressure in the arteries when the ventricles are filled with blood. So the ventricles are relaxed, and then the diastolic pressure is the lower number, which the blood pressure goes down to in between contractions of the ventricles. And so blood pressure, it can be measured with a sphygmomanometer and has a pressure cuff, which determines the amount of pressure that's required to stop the flow of blood through an artery. And this is expressed in millimeters of mercury. And so it's generally written in this kind of a manner here. So average pressures would be around 120/80. So blood pressure decreases as the blood flows from the aorta into the arteries, the arterioles, and the capillaries. And blood is under minimal pressure in the capillaries since the capillaries have a very high total cross-section area. So if you total up all of the cross sections of the capillaries, at least the vessels in the capillaries, then that's where the largest amount of cross section occurs. So as the blood goes to the capillaries, because there's so much greater space, the pressure then drops. Now to help deliver blood back to the heart, muscle contraction, especially in the legs, is very important for that actually. And so as muscles contract, they actually put some pressure on the veins themselves. And because the veins have valves in them in the lower extremities, then the muscle contraction can actually aid in the return of blood back to the heart. Um, Veins have a very thin wall, and the muscle contraction is actually not sufficient um, in the veins in order to return blood back to the heart. So muscle contraction actually aids in circulation. Note too that the valves are only located in the lower extremity, and so if you hang upside down, you'll actually have pooling of blood in the head, which is probably not a good idea to do for extended periods of time. So that looks at the flow of blood after it leaves the heart, and then that concludes our look at how that works.